What you're about to see is a portion of the conversation captured at Rajant's Partner Summit in Sicily in the spring of 2023. The segment we're going to look at shines a light on issues relating to uploading, coverage, and scalability when implementing an LTE network. You hear about the advantages of pairing an LTE network with a Rajant Kinetic Mesh, i.e. the Kinetic Mesh LTE hybrid network.
Solutions that appear viable in a lab or a limited test environment often fail to meet the mark when they're expanded beyond the simplicity of just one or two devices. It's a testament to the necessity of considering how technologies perform not just in isolation, but as part of a larger, more dynamic system.
I think one of the biggest difficulties when you're trying to, even if you're competing against LTE, is how they can't demonstrate it until it's in. That's one of the biggest problems, is LTE networks do take time to settle. It takes time to gather that coverage, just like and 5G networks as well. And so
to finally optimize.
Not only to optimize, but the whole system to settle down. You set up a mesh link, you know what your RSSI is, you know what the RSL is, you know those parameters, and you can tune it and fix it during the installation. What I've seen from port installations and their complexity and how they change is how LTE fails to adapt, I suppose, but also takes time to settle down into a state in which it's functional. And to demonstrate that technology, to demonstrate our technology as well, it's to do it on scale. But what I do know is that when you install more mesh nodes, you're strengthening your network by offering different routes for the data to travel, more redundancy, more capacity, and certainly with the processing power that we have now in some of the modern units. With LTE, you're always going to suffer with the same drawback, which is you include a subscriber, you are hindering your network. Like any TDD technology, you are drawing away from a central capacity. We're sharing attention all the time. We're not strengthening it. And so scalability is the big thing, I think, with ports anyway.
And this goes back all the way to the industrial equipment manufacturers. And this is both ports and mining. What we've seen is on that level with the original maybe testing of communication solutions, back at that source, they don't even scale. So we've seen this so many times that this works across this technology, maybe a 4G, 5G. Let's simulate, we're testing a single machine. Let's do 2 machines, let's do 3 machines. It seems to be working. Now let's deploy it. But in the real world, we are doing what? 10, 15, 20, 30, 40 machines, potentially, and ports sometimes up to 150, 200 machines. So we do find that scalability is mostly not being tested.
Now the conversation moves on to discuss network coverage. We often take for granted the coverage we experience with our mobile devices in urban settings, but as our experts will illustrate, the conditions in industrial landscapes are another world entirely. These are places where, as we've said, any infrastructure needs to be as dynamic as the terrain itself. You'll hear about the pitfalls of assuming that what works for our phones will work for a mine or a port, and once again, the practical hurdles when expectations literally meet the hard rock of reality.
How about coverage, general experience in coverage? Because I know we have a consistent issue, ports as well as mining, a coverage issue, and the difficulty in expanding that.
That's one of the other big things that they get sold. They look at their phone, they know they can get coverage pretty much anywhere. So they assume we're going to put 3 beads, we're going to have some sector antennas on a tower, and the mine is going to get covered. Well, the reality is, propagation works the way it works. It's affected the same way as all other RF is affected.
And mines change.
And mines change. 90-degree mountains appear out of nowhere almost overnight, where they don't have facility, and it's not a cost-effective functionality to start having ENO-Bs on multiple trailers and moving them around like you would.
It's not an easy process.
No.
Well, one thing that I was amazed at when I first came across the ENO-Bs was high power device meant to cover a very, very long range with directional antenna. And that thing was actually depressed to go into the mining area itself, right? So the whole range benefit was lost because we were actually now depressed into the working area of the mine. Yeah, that threw me a little bit, right? Because I was expecting to get 14-kilometer range, but we couldn't because the mine was only 5 kilometers long, and the whole thing was depressed all the way down. So now the focused RF is actually going into the pit. We've lost that long range capacity that we were told we were going to get.
So this brings up an interesting angle where if you contrast where kinetic mesh came from, it was developed from an industrial perspective. If you look at where cellular 4G, 5G was developed from, it was from a broadband, consumer-based broadband perspective, where coverage is measured in horizontal range.
Yes.
Where we come from, coverage is measured in some horizontal, but a large amount of vertical coverage.
Absolutely.
So once you get terrain deviation, this becomes a major issue.
Basic mining environment in surface mining environment, the bit goes deeper all the time.
Yes.
But on the other hand, the waste rock dump
It's
growing.
That's
So
it.
that's the big problem, because you need to be constantly changing the base station radios direction and adjusting
Line
those,
changes,
And-
right?
and
which
look-
is very expensive in overall.
Finally, the conversation moves to the most important topic, trust in the network infrastructure. It's pretty rough to realize that despite significant investment, the network that was installed doesn't inspire the confidence for critical operations. You'll hear about experiences facing a single point of failure that goes down with immediate and widespread repercussions, and how our partners stepped in with a solution that doesn't discard the existing investment, but rather enhances it by fluidly transitioning between mesh and LTE, ensuring that the best available route is always in use, eliminating single points of failure, and extending the life and capability of the network.
You don't fully trust what they have installed because it's based on coverage, right? If a node B fails, that node is gone, or that close to the crusher is gone, the coverage, right? So they call us and say, hey, we need something that can be worked together, because we spend millions of dollars on this and we can just not throw it away, right? So we come in, we have this node called Peregrine LTE. It seamlessly integrates with the core LTE. Basically, what we have to do, we install a slipstream, plug it to the core network. It's going to have a route through it, right? And then you plug the SIM card into the LTE node. It becomes a client. You plug whatever you need to plug behind that node, put in a truck, in a shovel, whatever. And then that node is going to now talk through mesh and through LTE simultaneously. One route is always the chosen one, so the other one is going to become like a backhaul, but it's already known. So let's say the mesh is pushing 20 megabits, and now that machine has moved, and then it now just needs 5 megabits, and LTE is better in that region. That's boom, gone. So mesh is going to be weaker in that region, and LTE is going to be better, for example. Or the node is needing 30 megabits. LTE in that area is gone. No 30 megabits.
So to summarize, how does the customers find this hybrid solution?
They find it very suitable. I mean, it's easy to install. It's just a regular node. You plug in the SIM card and gone. That's it. It's really good.
Problem solved.
Problem solved. And it is scalable. Really scalable.
Scalable.
And the mesh network is based on offload, right? So we are not coverage based. So as soon as we start putting APT through fiber or through a PTP link, that area is covered.
Yes.
Right. So you create a small node, a small area. This node on a drill is pushing 15 megs. LTE will not do that on certain bands. So that drill is pushing 15. That node is capable. That link is capable of 100 megs, and you are good to go.
With today's applications getting smarter and smarter, there's now more than ever a need for resilient, dependable, high-speed networks. With the Rajant Kinetic Mesh LTE hybrid network, you get the best of both worlds. You get the long-range coverage and backhaul of the LTE technology while keeping the redundancy, resiliency, adaptability, and high throughput of the Rajant Kinetic Mesh network. Together, your applications will soar, making sure your ROI achieves its maximum potential. Contact Rajant and we'll show you the way.